Good morning students. I am Vetri Chelvi from Vetri and Vetri NEET Chemistry. Today I am going to give the video to the topic of thermodynamics. Okay, now let us see the sum. Calculate the change in internal energy if delta H with the unit of kilojoules, pressure 40 atmosphere and change in volume is equal to minus 1 liter. Aiims 2007 question. So frequently I am telling Aiims questions are asking repeated in the NEET question. So we can expect the same pattern. Now let us see the question. Calculate the change in internal energy. They are asking change in internal energy that can be represented as delta U or it can be represented as delta E. So they are asking change in internal energy. What are the data are given is delta H is equal to minus 92.2 kilojoule that can be converted as a joule, that is kilojoule to joule into 1000. So your delta H is equal to minus 92,200 joules, and then pressure is equal to 40 atmospheric pressure and change in volume is equal to minus 1 liter. Okay, now let us go to the formula. The formula is delta H is equal to delta U plus, here it is given in terms of P and V. So I am going to take in terms of P and V. This formula having two format. Now I want this is, so I am taking here. Okay, now let us, this is the formula. One more condition, relationship is, what is the relationship is 1 liter atmosphere is equal to 101.33 joules. This format we need, that is a for conversion. 1 liter atmosphere is equal to 101.33 joules. So these requires, let us go for your substitution now. They are asking, that is your internal energy. Let us substitute the data. Here this is in the form of joules, you take it. Now this is, I am writing, substituting the value delta H is 92,200 joule is equal to delta U is the cosine plus your pressure is 40 atmospheric pressure into minus 1 liter. So this is your liter atmosphere. So that should be converted into a joules. So I am doing here delta U plus, keep it as it is. Here it is become 40 into minus 1 is become minus 40 into 101.33. Let me complete here delta U plus into minus minus, and this is I am going to take as a 40 into 101. So straight away I am doing the multiplication. This 0 I am bringing. 4, 1 is 4, again 4 into 0, again 4. So I am taking here as a round up of 101 into 40 and writing here. Okay, this is your minus 92,200. So this is the question. So you bring it on here, minus is become plus. So 40, 40, this is minus plus, minus of 92,200 is equal to delta U. Find out the difference. Here I am, for the convenience I am putting the subtraction here. This is minus sign, this is plus sign. So since signs are different, we have to go for subtraction. I am doing subtraction. 0, 6, 1 and here you are having 8 and 8 minus. So here I am writing minus 88,160 joule is equal to delta U. We want kilojoule is our option. So divide by 1000. What you are getting is minus 88 kilojoule is your answer. Let us go and see the option. Yes, B option you are having minus 88 kilojoules. Here children, some seems to be simple, but what are the knowledge is required? First you have to select this formula, that is the first one. Second one, the liter atmosphere converted to the conversion factor you should know. This is very simple factor, you take this methodology. Finally, the remaining things are very simple. That's all children. Let us go to the next question. Okay, now we are moving to the Aiims 2006. Okay, previously Aiims 2007, here 2006, let us see the question. The enthalpy change for the reaction. What is the reaction is given is Haber's process. nitrogen plus 3 molecules of hydrogen gives 2 molecules of ammonia. For this, what is given is delta H is equal to minus 92.38 kilojoules at a temperature is equal to 298 Kelvin. The internal change, internal energy change, that is delta U is equal to what? That is the question. So, this is the same question, same pattern, formula. The internal energy is asking, but different formula is stuck here because available data is for us only temperature. So, let me write now what is the formula for this. This is delta H is equal to delta U plus instead of P delta V, we are writing as a delta NGRT. So now based on the data, I am taking this formula. Okay, now what is the delta? Here what is delta Ng is number of moles of gaseous. Here you are having moles is product is 2. Here the reactant product is 4. For this sum, delta Ng is equal to number of gaseous moles of products. Everybody should know minus reactants. Okay. So what is this is only then 2 minus here 3 plus 1. This is 3 plus 1 4. So 2 minus 4 is equal to minus 2. What is minus 2 is delta Ng. Remaining thing we have to substitute of course. Now I am going to substitute it. Let us see. Here delta H is I am starting from this direct here. That is here it is kilojoule. You convert in the form of joule itself. Then we can go with your 92.333. This is in the form of unit is joule is equal to delta U is the question plus what is delta Ng is minus 2 into R value is 8.314 because joule into temperature is 298. Now what is the simplification roundup work I am going to do here? Minus 2 into 8 into this 298 I am taking as a 300, that is 3 into 10 power 2. So here I am doing 8 into 3 24, 24 into 2 48 into 10 power 2 it is minus. Okay, this is we will bring it on the next side. This is that is here of course. Now this is minus coming here. So 48 this is 200 and 4800 minus 92,380 is equal to delta U. So this is on simplification. This final is this one we have to do. Let me do the subtraction here. This is the corner I am using. This is minus 92,380 and plus sign 4,800. Since the signs are different, I am going to subtraction. Here, yes, 7, yes, 5. Okay, next here, yes, 11, 4 subtraction, 11, 4, you are having the 7. Okay, and then 8 minus sign. Let us check it, of course. Yes, correct. So your answer is now here I am writing this answer minus 87,580 is equal to delta U. This is in the kilojoule. Convert as a joule, divide by 1000. So our answer is approximately minus 87.5. We can see here option is minus 87.42 kilojoules. Okay children, here what is again repeating the knowledge. First one selection of the formula. Second one calculating the delta Ng. Third one simplification, that is here I am doing calculation with nearing roundup to complete the sum very quickly. For this you require a lot of practice. You practice more sum like this children. Okay, now let us go to the next question. The value of delta H and delta S for the reactions are 30 kilojoule per mole and 100 joule per Kelvin per mole. Let me write first. Delta H is equal to 30 kilojoule per mole. Delta S is equal to 100 joule per Kelvin per mole. Okay, yes. then the temperature above which the reaction becomes spontaneous. So they are asking temperature to keep the process as a spontaneous. This is the task. Now let us go to the very simple question. Okay, it is recently they asked this question in the NEET. So now what is the formula is delta G is equal to delta H minus T delta S. For spontaneous condition is this should be equal to 0 delta H minus T delta S. So now let us keep it as a 0 mean bring it on the next side. This is for spontaneous. For spontaneous. I told the conditions for spontaneity is this should be 0 or it should be negative. To give delta G as a negative, the reaction is spontaneous because they are asking above which temperature the equation is spontaneous. So that I am keeping this is as a 0. Let us assume it is a 0. That is the value should be less than 0. So I am keeping as a 0 now. Now let us see the next point, that is your delta H. You keep the minus delta here, bring it on the next side. So T delta S is equal to delta H. They are asking temperature. So temperature is equal to delta H minus delta S. Now let us go for substitution. Sum is having 30. You can see here 30 kilojoule per mole divided by it is kilojoule. So what we should do it convert as a joule. So I am doing here multiply by 1000 and it's become now it is joule. So 30,000 joule per mole. What is the delta S values? Entropy is 100 joule per Kelvin per mole. Since it is given as a joule, the kilojoule is converted in terms of the what is it called as joules. Okay, now you are getting 2 zeros getting cancelled. What is remaining is 300 and joules and joules getting cancelled, mole cancelled. You are getting Kelvin here denominator coming as a numerator. So your value is 300 Kelvin is the temperature. So now this is here 300 Kelvin is available here. So above the 300 the reaction is spontaneous. Again I am repeating, for spontaneity keep it as a 0, bring it on the next side, and delta G is this is called change in Gibbs free energy, enthalpy, and temperature is change in entropy. Conditions for spontaneity, you might be know what is delta G is the Gibbs free energy. It should be always negative. Keep it in the mind, do it. Thank you children.